Hey everyone, so this is going to be kind of a part one of properties of exponents. In this video we're going to look at the first 5 properties. Let me just talk through these real quick. For property 1, when we are multiplying two things with the same base that have exponents, we add the exponents. The reason for that is, I never remember to set up the pen. There we go. Oops. So if we have x to the second times x to the third, that is the same thing as we have 2 x's and then we have 3 more x's, because x squared means x times x, and this means x times x times x. And if you count those, they make x to the 5th. And so that's when I am multiplying with exponents, then we add the exponents. Property 2 says when I'm raising something with an exponent to a power, then I multiply the exponents. So it's a little hard to remember, but when you multiply, you add. When you raise to a power, you multiply. The reason for this is if I have x squared cubed, so according to this property, that should be x to the 6th. If you think about what x squared cubed really is, that means we have 3 x squareds. That would be cubing x squared, and there's 2, 4, 6 x's there, so x to the 6th. Properties 3 and 4 are just actually an extension of property 2. This just says when I have an exponent outside of parentheses with multiple things, that everything gets raised to that exponent. Same thing for a fraction. The last one that we'll look at in this video is property 5, and this one says when I have division, I would subtract the exponents. So if you think of something like x to the 5th over x to the 3rd, according to this property, it would go x minus y. I'm sure it's really small on your screen, but that's what that says, is x minus y. So 5 minus 3 would leave 2, and again that makes sense because if I think of this as canceling instead, I would have 5 x's up top, I would have 3 x's down below, and then if I cancel out the common x's, I'm left with x times x, or x squared. I like this version of thinking about it for the next video where we get into negative exponents, because if you think of it as canceling, it's easy to see whether the x's belong in the numerator or the denominator. I guess the one last thing that we will look at in this is anything anything other than 0 raised to the 0 is 1. And the reason for that is if we think about x squared over x squared, and we apply property 5 there, that would be 2 minus 2, and what we get is x to the 0, but x squared over x squared, those reduce, right? And so that would also equal 1. So anything to the 0 just means that you had the same thing in the numerator and denominator, and it reduces down to a 1. So let me show how those would work with some examples. For this first one, we just have 3 things multiplying, so we would multiply the numbers just as we always would. Let's see, let's go 6 times 5 would be 30, times 3 would be 90. I did that because I'm better at that than I am at 18 times 5. But so the coefficients are going to come out to 90. And then x to the 5th, x squared, x to the 7th, so those are all multiplications. And so we would be adding the exponents. So 5 plus 2 would be 7, plus another 7 for, sorry about the noise there, x to the 14th. For this one, again, we multiply coefficients, and then we do our like terms together. So x's will go with x's, y's will go with y's, etc. So 7 times 4 would make 28. X squared here times x to the 8th, so that would be 2 plus 8, so x to the 10th, because that would give me 10 x's if I wrote those all out. 3 y's here, 4 y's there, so that gives me 7 altogether, and then z to the 6th. And that's kind of all there is to using property 1 there. For 19, this is where we would subtract. So let me go ahead and write that out, what this would be. This would be 39 minus 17, and then in terms of the y's, that would be 79 minus 14. So if I do that subtraction, I get x to the 22nd, and y to the, that would be 65. and that would be as far as we can take that. In the next section, these may come up to negative numbers, and we'll look at that then, and that's those last couple properties. You can also think of this as if you had 39 x's up top and 17 down below, and you canceled them out, what would be left? With this one, that's a little harder to see because the numbers are bigger. This is actually a better example for that, so I'll treat this one kind of more that way. So for 20, I have 25 over 12. Nothing reduces there. This is 25 is 5 times 5. 5 still going to 12. So that fraction just comes out front, 25 twelfths. And then if I think about having 12 x's up and 5 down, if I canceled out 5 of them, I would be left with x to the 7th, which is the same thing as saying 12 minus 5. Again, in the next video, when we have 5 x's up and 12 down and we cancel out 5 of them, it will be helpful because we'll be able to see that those 7 should be down in the denominator rather than the numerator. So 2 ways of looking at it. Here, 18 minus 7 would leave 11, or again, if we thought of canceling it, we would have 11y's left in the numerator. And I think this was the format for the answer, but another way of writing it that is equally correct would be like this, with the 12 down below. But when it's just a single fraction, nothing else, they often will just write the fraction out front. These next couple examples are not, they're not any harder than what we just did, other than there's these signs that we have to keep track of. So I would think of when you have a negative, let's just use -1, raised to an even power, that's going to equal +1. And that's because you're going to have an even number of negative signs, and so anytime, if this had been x to the 12 instead of x squared, it would still be an even number of negative signs and it would come out to a positive. If I have something raised to an odd power, we'll use 3, but it would be the same as if it was 7 or 49 or any odd number. That means you have 3 negative signs, and so 2 of them will pair off and make a positive, but then the third one always makes it negative again. So when you raise to an even power, you're going to get a positive answer. When you raise to an odd power, you're going to get a negative answer. So looking at this one, I wouldn't even worry about how I was going to write that. I would write it's going to be negative because a negative to an odd power is still negative. And then 4 cubed, 4 times 4 would be 16 times 4 is 64. And then here we're raising this to a power, so remember that's the, that's the property up here where when we raise to a power we multiply. So 14 times 3, and that would give us y to the 42nd. For this one, we got to be a little careful of that. Inside is going to come out positive because it's raised to the second. Actually, let me write out longhand what this would be. It's -1 times -5y times -5y. So the squared, we're going to get a positive 25 in there, but then it's going to be reversed because of the sign in front. So -5 times -5 would be positive 25 with the sign reversed, so -25. And y times y, you can think of this y as having an invisible 1 right there. So 2 times 1, y squared, or y times y, also y squared. So that's kind of how to handle when you have signs with exponents. Here, this is just kind of a combination of properties, and we'll see more of that in the next video. So x to the 8th cubed, that means we have 3 sets of x to the 8th, so that would be x to the 24th, that's a bad looking 4, over x cubed. And then we would be dividing, so that's our subtraction property, so 24 minus 3, or think of canceling out 3 of them, and you have x to the 21st. This 4 applies to everything, both the numerator and the denominator, because the parentheses are around the entire fraction, whereas this one they're only around the numerator. So we have a negative to an even number, so like I was saying up there, that means that's going to come out to a positive. 4 to the 4th, I'm going to cheat and look at my notes, that is 256. And 3 to the 4th is 81. and then x cubed raised to the fourth, so that's 4x cubed, so that would be x to the 12th. And then this last one has a couple of 0 exponents, so that's going to mean that a couple of things in here are actually ones. So let's see, this would be 6x cubed, and then y to the 0, that's a 1. So rather than write times 1, I'll just leave it off, but that reduced down to a 1. And then that's going to be times 5. X to the 0 is 1. So writing this a little bit more simply, it would equal that. And then 6 times 5 is 30, and then x cubed for the variable. And that's kind of it for this part 1 of properties of exponents.